Hello and welcome to this video on how to run latent profile analysis in Mplus. My name is Geiser. On this channel I present weekly statistics tutorials related to structural equation modeling, latent class analysis and other multivariate methods, and often related to the Mplus software. In this video here I want to discuss the Mplus output for a latent profile analysis. I have a separate video in which I discuss the input file and the syntax commands in detail. If this is something that you haven't checked out yet, then please take a look at the description for a link to this video where I discuss the input file. Also, check out the description for additional resources and don't forget to subscribe to this channel and to hit the like button in case you like this video. I want to go over the most important sections of this output file here. And so you can see from the first portion of the output that the input instructions, the syntax instructions here are reproduced by Mplus. This is a latent profile analysis with 5 variables, and specifically we analyzed here the big 5 personality scale scores. We used continuous variables as is typical for latent profile analysis, and so in this case the 5 variables that were analyzed here were emotional stability, extraversion, openness, agreeableness, and conscientiousness summary scores from a scale that measures these personality traits. In this case, we extracted 3 latent classes, and so you can see this here again from the classes equals L3 subcommand. So now let's take a look at the output file in more detail. And so when you run a latent profile analysis like this in Mplus, the first statement, so to say, a warning that you get by default for a standard latent profile analysis is that all variables are uncorrelated with all other variables within class. So this is a warning that you will always get when you run a standard latent profile analysis, because the standard assumption in latent profile analysis is that you have no within class residual associations between your variables. Now you could have that, of course, you could allow for covariances between specific pairs of variables within one or more classes, but typically we don't do that at the beginning, because we want to try to explain all the associations between the variables by extracting multiple latent classes. So basically we want to have local independence in the classes, and then only in specific circumstances would we allow for within-class association. So this means, in other words, typically you can ignore this warning message unless you have a specific reason that you want to have within-class associations between specific variables. So this is not a warning message that typically concerns us when we do standard latent profile analysis. And then here you can see that this application is actually based on a real study. The data are simulated, but it's based upon a real study of big 5 personality traits. If you're more interested in the specifics of this application to the big 5, then you can refer to this paper here published in the Journal of Personality and Social Psychology, where we presented actual data applications of latent profile analysis to big 5 scores in different countries and also across time. In this particular application, there were 753 people or participants, and this is a pretty good sample size for a latent profile analysis with 5 variables and 3 classes. I often get asked, what is the sufficient sample size for this type of analysis? And it's difficult to say in general, but I would say you should have at least a few hundred. So like as a rough guideline, I would say don't do a latent class or latent profile analysis when you have fewer than 300 cases. So there are situations where that may be okay, but typically we want to aim for sample sizes that are above 300, roughly speaking. So here we're in a range where we should be fine. And then when we scroll down, you get a bunch of technical information that I don't want to go into the details of right now. After that, you get the sample statistics. If you asked for Samstat in the output option in Mplus, you can take a look at the observed means, covariances, and correlations across the entire sample. And then you also get univariate sample statistics, where you can take a look at things like skewness and kurtosis, minimum and maximum, percentiles, and the median as well. So this is not specific to class analysis. You would also get that for structural equation model, a structural equation modeling analysis, or path analysis, something like that, if you ask for Samstat. And then you get a ranking of the log likelihood values, and that is actually something that I do want to spend some time on explaining, because this is very important when you run latent class analysis, latent profile analysis, or other types of mixture distribution models, that you take a close look at this listing of the log likelihood values, because this allows you to identify potential local maxima when you run into a solution that may not be identifiable for the data at hand, or maybe you didn't run enough starting values to identify the true maximum likelihood solution for a given set of data. And so this allows you to diagnose potential problems with local likelihood maxima, which you do want to avoid because they may be associated with an invalid class solution. And so what is important here is to check that the best log likelihood value that is given in the first column here, that this has been replicated at least a few times with different sets of starting values. You can see here that we ran in this analysis different random starting value sets to see if we could replicate the same solution across multiple sets of starting values, and that was the case here. You can see that all of these log likelihood values here are identical. When we scroll down, you can see they're all -7,128. And so this is fine. So this shows you that this solution has been replicated across these different sets of starting values, and it's been replicated a sufficient number of times so that we can be confident in this solution. Now, when should you be concerned? You should definitely be concerned if this first value up here is the only one that looks like this. So if all the other values are different, then that is not a good situation. And so that also Mplus would then give you a warning message below this listing of log likelihood values, saying that it hasn't been replicated and that you should rerun with more starts. In this case, we are okay. And so this is also indicated by Mplus here, saying that the best log likelihood value has been replicated, and then Mplus will still recommend that you rerun with at least twice the random starts to check that the best log likelihood is still obtained and replicated. So if you're super concerned, then you could do that. You could go back and just increase the number of starts in the analysis option using the starts subcommand to see if you still get that same log likelihood value of -7,128. In this case, it looks fine, and it's not going to change anything here. And typically also when you have only 3 classes and a sufficient sample size, then you should be fine. It's typically more of an issue as you go higher, 4, 5, 6, 7 classes, then the solutions become a little bit trickier to identify. Otherwise, the model estimation here terminated normally. That's always something that you want to check, that there's no error message here about estimation issues. And so then we get a bunch of fit statistics here, the log likelihood value again. This is the one that we already saw. And then also we get information criteria that we can use to compare different models. So for example, if you wanted to find out, is 3 classes good, or do I need 4 classes, or are 2 classes sufficient, you could compare the information criteria values across solutions with a different number of classes. And that's often what we do in latent profile analysis and latent class analysis to identify the best solution. In particular, we often take a look at the BIC or sample size adjusted BIC values to determine the number of classes. Below that, we get the proportions for the latent classes based on the estimated model. And so those are the parameters that indicate the class sizes. So those are the class size parameters. You can see here that the first class had about 35% in it, the second class 27%, and the last class was the largest class with 37%. And in the middle, you can see what approximate number of actual individuals these percentages correspond to. So about 266 people were in class 1, 206 people were in class 2, and about 280 people were in class 3 based on these estimated class sizes. And you can also see that they add up to 100%. So when you take these percentages and you sum them up, then you will get 100%, because everybody is assigned to one and only one latent class. So this gives you the class sizes. And then let's scroll down a little bit. You get an entropy measure as well, which is something that I don't find particularly useful as a fit measure, but some people like to look at the entropy measure as a summary measure of the classification accuracy. What I find more useful are these average latent class probabilities for the most likely latent class membership, which allow you to look at the reliability of classification in each class. So when you look at the diagonal here this value, and this value, then these diagonal values, they indicate the average probability that was attached to individuals who were assigned to a particular class based on their most likely latent class membership probability estimate. And so you can see on average those individuals who were assigned to class 1 had a 90.8% chance of being in this class. And that's really high. So they had on average a very high chance of actually belonging to this class. And then for class 2 it was about 80%, and for class 3 88.3%. So those are good average class assignment probabilities, showing that individuals on average were classified with high certainty, that the classes were well separated. And so that's something that you want to take a look at. You don't want off-diagonal probabilities that are too high, because then that would indicate that some individuals cannot really be classified well into one class, but where there's uncertainty across multiple classes, and that means that the solution may not be so well defined, the classes may not be so well separated. Okay, let's go down a little bit, and then at the end you get the model results. The model results essentially in latent profile analysis are the estimates of the class-specific means. That is the key parameter, so say in a latent profile analysis, that we look at is what do the means look like across these continuous observed variables across different classes. And so you get latent class 1 here first, and you can see the means are first for our 5 variables, for our 5 latent class indicators. Again, those are personality scale scores. ES is emotional stability, E is extraversion, O is openness, A is agreeableness, and C is conscientiousness. And so you can see what the means were in class 1. And then also you get variance estimates for these indicators. And that's it, so to say, for each class. Then already you get the means for class 2 and the variances for class 2, and then the same for class 3. Notice that the variances are automatically constrained to be invariant across classes in Mplus. You can see this here. Here at the top, I highlighted the variances in class 1, and you can see that they're the exact same as the variances in class 2 and also in class 3. And so this is a constraint that Mplus automatically puts in to have a better defined solution, so to say. So that helps us with the sharpness, so to say, of the mean profiles. If you were to estimate those variances freely across classes, then oftentimes the solutions can become a little bit unstable. And also then the mean profiles often are not so well defined between classes, because then some of the variability can be accounted for, absorbed within class variance or across class variance differences. And so I have found that oftentimes when you estimate all the variances freely, you end up with a solution that's not so easy to interpret. Now, that being said, it doesn't really make so much sense oftentimes theoretically to assume that these variances must be equal for all indicators across all classes, because why should they be? If you have, for example, a large class, that class may show more variability, or if you have other reasons why some classes show more variability. And you can free these up, these variances. They don't have to be constrained equal across classes. You can lift that constraint by including a model statement in Mplus, and that is definitely a possibility, and oftentimes it's recommended that you check out different variance specifications as well, but the Mplus default is that they're held equal across classes. So you have to think about that in your own application, whether or not that makes sense, this constraint. It's good to know, so to say, that this is what Mplus automatically does, and it may not be what you want under all circumstances. What we really, so say, look at for the interpretation of the classes are not the variances, but typically those are the means. And so it's relatively difficult to make this interpretation by just looking at the means. You can, looking at the numbers, because there are a lot of numbers. So you can see a little bit that class 3 has higher means than class 2 on all indicators, and you can see that when we scroll up again, we can see that the means in class 1 are higher for some indicators than in class 2, but it's kind of difficult to process all that information from just the numbers. And so what we typically do is we look at a plot of the mean profiles, and so Mplus offers a possibility to do this by clicking on the plot option here in the menu. If you selected the plot command, or if you had syntax related to the plot command, then you can go to plot and then view plots, and then go to estimated means here in the middle, and then view. And so the default is that the plot will show the estimated means in those classes or across those classes, and that all classes will be shown in the same plot, which you typically want, because then you can look at you can directly compare those profiles of the estimated means. So you just hit OK, and then you get this plot of the class-specific means. So they show exactly those 5 means that we just looked at in the output. At the bottom, you don't have the labels for the variables, so it's a little bit awkward, but those are the same variables. Emotional stability here is 1, extraversion is 2, and then openness, agreeableness, and conscientiousness are here depicted on the x-axis, and the lines show the means. And so you can see we have one class, class 3, that has high values on the big 5 throughout. So those would be called the resilients, because they have high emotional stability, high extraversion, high openness, high agreeableness, high conscientiousness. It's all good, so to say. All those are beneficial to have in terms of personality traits. And then we have a class that is high, especially on agreeableness and conscientiousness, the blue class 2, but is lowest on emotional stability, is lowest on extraversion, and lowest on openness. And those would be called the over-controllers. So they have a little bit of issues with neuroticism. They have higher neuroticism, lower emotional stability, and they're very conscientious. So they're kind of over-controlling everything. And then we have a third class here, the red class, where we have, this is actually class 1, but this is the one that I'm discussing last. So the third class that I discuss here is in the middle with regard to emotional stability, extraversion, and openness, but is especially low as the lowest class on agreeableness and conscientiousness. So these people aren't conscientious, so they're under controllers, as we say, so they're a little bit all over the place. And so that is something that could also cause trouble, and it's kind of like the opposite of the over controllers. What you want to be, typically speaking, would be you would want to be resilient. You would have to have high scores on all the big 5. So say that would be the resilient personality type that would be most beneficial. So that's what came out here of this 3-class latent profile analysis of the big five. I hope you found this video useful. If you did, then please don't forget to hit the like button. Also, don't forget to subscribe to this channel and to check out the description for additional free videos and workshops and other resources, and I'll see you next week.